In section 3.2, we're going to talk about the addition and subtraction property of equality. The addition and subtraction property of equality says the following. If you have two things that are equal, meaning they have exactly the same value. Okay. Let's just suppose it's something like, I don't know, x equals to a. What the addition and subtraction property says is if you take those two things that are equal, and if you add equal amounts to them, so let's suppose c is some real number, and you add c to both sides, then those two things will still stay equal. Similarly, if you start with two things that are equal, and you subtract the same amount from both of them, they will remain equal. Think of it kind of like a scale. If you've ever seen like a scale that people use to kind of like weigh things. Okay. If the scale is balanced, meaning you have as much weight on one side as you do another side, and let's suppose you go ahead and add 5 pounds on one side, we know what would happen. The scale would then become unbalanced and it would start to go down. But if you add another 5 pounds on the other side, then it would still maintain that balance and that equality we had originally. And we can use this property of equality in order to solve some basic equations. Okay. When we say to solve an equation, by the way, what this means is to find the value of the variable x, or whatever variable you're using, that will make a true statement. So in this case, instead of using the variable as something that's a varying quantity, it's used as a placeholder for an unknown number that we want to find. If I write this equation even without using the variable x, for example, in example 1, I could write it just kind of abstractly as some unknown number minus 3 is equal to 8. Our job and our goal is to find what is that missing number. Now, most of you can just look at this equation and see exactly what the answer is going to be with just doing the smallest amount of mental work. That's not the point. What we want to do is develop a pattern and an algorithm and a way of doing things so that when the equations get more difficult and much more involved, we have a process that says if you follow this step by step by step, no matter how crazy or involved the numbers are, that we will always get the correct solution, the correct answer. So here's how we're going to solve this. If I have x minus 3 equals to 8, my goal is to make it look like x equals to a number. I want to get the x by itself. Right now, the x is on the left-hand side of this equation. So a lot of times we say like left side, right side. If you imagine kind of like an imaginary line cutting through your equal sign, that's what divides the left part of the equation from the right part of the equation. In order to get the x by itself, we would want to get rid of this minus 3 that's over here with the x. And to get rid of minus 3, we would need to have its opposite. We would need to have an addition of a plus 3. But I can't just add 3 to one side of an equation without also adding 3 to the other side in order to keep it balanced. On the left-hand side, the negative 3 and the positive 3 cancel because you're adding opposites. So they add to 0, which is just going to go away. And we would get x equals to 8 plus 3, which is 11. So the solution to this equation is x equals 11. One of the things that's really nice as it pertains to solving equations is you can always check your answer by plugging it back in. If I go back to the original problem and everywhere I had an x, if I replace it with 11, is it the case that 11 minus 3 equals to 8? Well, the answer is yes. And so that would let us know that we did solve the equation correctly. Let's take a look at another one in example 2. We want to solve x plus 7 equals to 5. Here's my equal sign. Again, you can kind of think of like an imaginary line that divides it into the left half of the equation and the right half of the equation. In order to solve it, we want to find the value for x. So we ultimately want to make it look like x equals to some number. In order to get the x by itself, we would need to remove the plus 7 that's on the same side as the x. The opposite of adding 7 is subtracting 7. So we're going to subtract 7 from both sides of the equation. On the left-hand side, the positive 7 and the negative 7 would cancel each other off. So we would get x equals 5 minus 7 is something we did in the previous section. Well, 5 minus 7, we know that that's going to be negative 2. So the answer to example 2 is going to be negative 2. Let's take a look at example 3. This is one that maybe you can't do off of the top of your head. But again, let's fall back on the basics here. We want to solve the equation, so we want to get the x by itself. Notice this time that the x is on the right-hand side of the equation. That's where our attention should go. In order to get that x by itself, we notice that what's with it is a negative 2/3, which we need to get rid of. The opposite of subtracting 2/3 would be to add 2/3. So we're going to go ahead, and if we do it to one side, we also have to do it to the other side. So I'm going to add 2/3 to both sides of this equation. On the right-hand side, those will cancel. The negative 2/3 and the positive 2/3 will combine to give us 0. And we don't need to put x plus 0. We can just call that x. And our answer is going to be found by doing this arithmetic that's over here. We have a negative 1/2. And we're adding to that negative 1/2 2/3. We've already discussed how to add fractions in a previous lesson. We need to get a common denominator, which in this case is going to be 6. If you change a half into 6, that's going to be negative 3/6. If you change 2/3 into 6, that's going to be 4/6. And now that we have the common denominator, we can add the numerators. Negative 3 plus 4 is going to give us 1/6. So the solution to this equation is x equals 1/6. Here's another one that's a little bit more involved, but it's very similar. One of the first steps as we kind of move through this chapter and we come across some more involved equations is we want to start with each side in simplest terms to begin with. So again, I can kind of think of an imaginary line that cuts through my equation. So over here is our left side, and then over here is our right side. So we're not worried about doing anything to both sides until we start with two sides that are in simplest terms to begin with. Notice on the left-hand side of our equation, we actually have 1, 2, 3, 4 terms altogether, and that actually includes two pairs of like terms. For example, the 5y and the negative 4y are like terms on the same side of the equation, so we can just go ahead and directly combine them. 5y take away 4y would be 1y, which we can write as just y. We have a positive 3 term and a negative 8 term. Those will combine to give a negative 5 term. Over on the right-hand side, there's two terms here. They're both like terms. They're just constants, so we can combine them. 6 plus 9 would give us 15. We haven't done anything to change the equation other than we just simplified each of the respective sides. Now that each side is simplified, we want to turn our attention to where is my variable at. Well, the variable is on the left-hand side of the equation, and the thing that's over there with the variable y is that subtraction of 5. We want to get rid of that. To get rid of the subtraction by 5, we would need to add 5 to both sides. The negative 5 and the positive 5 would cancel, and so we're left with y equals 15 plus 5, which would be 20. So our final answer would be y equals to 20. Let's take a look at another one. In example 5, we are asked to solve 4x equals 7 plus 3x. This one is a little bit different in that each side is already simplified to start, so that part's done for us. However, whenever we try to solve, remember, we want it to make it look like x equals a number. And when you do that, your variable should be on just one side of the equation. In example 5, we have x's on both the left-hand side of the equal sign, and we have x's on the right-hand side of the equal sign. So the very first step we would need to do is we need to move all of our x's to one side. And in general, it doesn't matter which side you choose to move them to. I'm not picky. You can do whatever you think is easiest. With a little bit of foresight down the road, it usually will turn out to be better to get rid of the smaller amount of x's from one side. So if I'm looking at a positive 4x compared to a positive 3x, the positive 3x is smaller. So what I'm going to do is I'm going to subtract 3x from this right-hand side to get rid of it. But if I do it to the right-hand side, then we must also do it to the left-hand side. On the left-hand side, 4x's take away 3x's will leave us with 1x, which is just x. And on the right-hand side, the positive 3x and the negative 3x cancel, and we're left with just x equals 2 to 7. And as a result of that, that actually gives us our answer, x equals 7. Let's take a look at example 6. It's a very similar type of problem where here's our equal sign. So we imagine the imaginary line cutting it into two halves, the left side and the right side. If I look at what over here on the left-hand side, that's already simplified. There's nothing we can do here. They're not like terms. And similarly on the right-hand side, nothing to do there. So both sides are already simplified. The next step we go to is we try to locate our variable. You want to ask the question, is it on the left side, the right side, or both sides? And this answer is we have the variable on both sides of the equation again. Because of that, that very next step should be to move the y to just one side of the equation. And I'm going to do so by getting rid of the smaller amount. Between positive 3y and positive 2y, positive 2y would be the smaller amount. So if I want to get rid of positive 2y's, I'm going to need to subtract 2y's. And whatever I do to one side of the equation, I also have to do to the other side. It's always a good idea that as you're working through these, try to get into good habits. Always bring your equal sign straight down. Try to write things nice and orderly. Notice that when I'm subtracting or doing something from both sides of the equation, that thing that I'm adding or subtracting, I always try to write it under the term that it's like on that side. That way it'll kind of be easier to read and combine them as we move down. 3y take away 2y will leave us with 1y, which is just y. On this left side, the negative 9 comes straight down. On the right side, the positive 2y and the negative 2y cancel. They add to give 0, so we don't need to put it. And we still have that positive 6. With that move, we have now successfully moved the variable just to the left-hand side of the equation. So that's where your attention and focus wants to go. In order to get the y by itself, we would now need to get rid of a subtraction by 9. And to do that, we would need to add 9. And whatever I do to one side of my equation, I have to do to both sides. These would cancel, leaving us with y equals 6 plus 9, which is 15. So our solution is y equals 15.